Hi, welcome to the YouTube channel of Independent Science and News. This week I'd like to introduce a new scientific paper that was just published just a couple of days ago, and it comes from the lab of Professor Gilles-Eric Seralini, who is famous for his studies on GMOs and rats, and also for, in my mind, studies on, for example, the quality of animal food fed to animals that are being tested for the effects of pesticides. So he's done important work, for example, showing that controlled diets that are fed to animals in experiments have high levels of pesticides already in them. So they're not actually functioning as controlled diets. So he's done a lot of really interesting work. And one of the things that's interesting about Seralini is that he's often doing creative, innovative, and interesting experiments that, in my opinion, other people could do, but there are very few people who are actually doing creative, interesting work in the field of pesticide toxicology or any kind of toxicology. They're more interested in producing results along very limited lines, when actually there's many more things that could be discovered about toxicology. And so this paper that I want to introduce today is about taste testing of pesticides, whether people who are wine tasting experts can taste the pesticides in wines or not. And so first of all, what he did was he spent his time, so his co-author, by the way, is called Jérôme Douzelet. But the two of them, basically, they analyzed the content of pesticide content of wines and compared it with neighboring organic farms, vineyards, and to see whether experts could tell whether there were pesticides in these wines. And the first interesting thing that they did was they measured all the pesticides they could find in wines. They found hundreds of pesticides in these wines. And secondly, what they did was sum up. This is kind of an interesting approach, is to basically, individual pesticides were present at about 200 parts per billion, but the total amount of pesticides in these diets was about 4,000 parts per billion. But wines varied quite considerably. But what they do show in the first place is that wines contain quite a lot of pesticides, right? That's 4,000 parts per billion is really quite a lot. And the second part of the paper then goes on to ask the question of whether people can taste these pesticides or not, at least wine tasting experts. And they show, for example, that many of these pesticides are present at higher concentrations than other chemicals that people do taste in wines, right? There are certain, well-known flavor compounds which are present at lower concentrations than these pesticides. So there's no reason a priori why they shouldn't be able to taste these chemicals. And so they do taste tests, for example, of pesticides also in water, right? So they got these experts to determine what is the flavor of various pesticides, and that was kind of a fun thing to be able to do. And so let me read out to you some of the famous pesticides and what they taste like. So dimethomorph tastes like cardboard rag, drying and biting. Cyprodinyl, which is drying, astringency and bitterness. And iprodione has an irritant, bleach and old burned plastic taste to it. And then there's an interesting one, glyphosate. So there's been all these discussions of people drinking glyphosate, that you can drink a whole can of glyphosate without becoming sick. But none of these people who claim to have done it have ever told us what it tastes like. But according to these wine tasting experts, it tastes like strong dryness, acid, acrid, and limestone. And so that's glyphosate. Glyphosate itself. Roundup, which is obviously a mixture of a large number of chemicals. The flavor of Roundup is putrefied wood, drawing and bitterness. And so those are kinds of interesting set of experiments there that kind of emphasize also an interesting thing is that, you know, what a person can do chemical testing of complex mixtures of compounds, but, you know, some of the most sensitive detectors of substances in the environment are organisms, right? And so there's great research, for example, using animals to detect landmines and so on and so forth. And what this kind of brings home to me is that for all our technological wizardry, there are actually is still plenty of room for using organisms and biological organisms as tools in science. And this paper is one example of them that actually are superior in many ways to the, you know, mass spectrometry and all the fancy machines that people use. You can actually get interesting and important results from using biological sensors. And so it shows, you know, in the last analysis, the power of the natural world to generate scientific results. And so I think this is a fun and interesting paper. So thanks to Professor Seralini for putting this out there. And so that'll be the end of our YouTube channel today. But please subscribe more for more interesting scientific findings and analysis. And we will see you next week, hopefully.